Hi, welcome back. So you've seen in the previous videos how we can create a relational database table and how we can query it. Okay, it's a little more structured than say a spreadsheet table, but using the SQL language, we can write queries that allow you to get data out of that table in a more powerful way. Um, so in a real relational database, though, you don't just have one table, you have a whole bunch of them. Relational databases were first described by a guy named E.F. Codd in this paper um, in 1970, because an IBM researcher. And it was really a design that was about how to make a database that is flexible, can be queried in a whole bunch of different ways. And it has a bunch of different methods. But really what we do is we have a whole bunch of different tables. Now let me show you how having multiple tables rather than one big table makes a more powerful, a better structure. All right, so what you see on screen here is a spreadsheet, Google Sheets, and it's a simulated table. And this is how we might have our bids in our online auction site. See if I can zoom in a little bit more for those of you with small screens. Okay, and so here we have a table, and the columns are listing, starting price, auction end date, the seller name. This is kind of like the listings table we already did, although there would be more columns for a listing. And then the seller email, the bidder's name, the bidder's email, and then how much they're bidding in dollars, right? And so these are all bids on one product. And if you're building if you're trying to tally up bids in an auction, and imagine there'd be more and more rows for different products and different bids and different bidders, you'd have thousands and thousands or millions and millions of rows, or if you're something like eBay, probably billions of rows at this point. And one of the problems with this is that there's a lot of duplication. Okay, so the product's name is there, duplicated 10 times or so, the seller's name, the seller's email, all the data about the auction is repeated many, many times. Even the bidders, if they come back and bid more than once, their name and their email is repeated. So what if, let's say the seller changes his email address, or what if she changes her last name? Or the same with the bidders. Or what if the auction end date is changed? Now you have to update this in multiple places. And if you're writing an automated system that really is just tallying up the bids, it may not have any interest in going back and editing the previous data. It's just going to change the data for the further rows going forward. So you end up not knowing what Joe C's email address is, because you have earlier rows that have one email address and later rows that have another one. These are called anomalies, and we'll talk more about those in the future lessons when we talk about normalizing the database. But essentially, you have a lot of duplication. You have a lot that you have to keep track of, a lot of possibilities for errors to get in there. And it's also, it reduces the flexibility, right? You can't easily add another concept to this, like, I don't know, comments, right? Or storefront or something. Everything's in one big table. So what a better design, a more relational design, is to split this up into a bunch of different tables. So for example, that seller information, you could have it in a table of sellers. Okay, so Joe C, we've got his email address. And you give him an ID number. So then in your listings table, instead of having seller name, seller email, seller all this, you have seller ID, right? And so these two tables are related by that seller ID. Anyone that's looking at the listings table, they get all the information about the listing. If they want to also know about the seller, they can follow that link. That ID number 1 tells them which row of the sellers table to join in. And in SQL, we can join. It's called a join when we can combine two tables in the result. The same with the buyers. We can have a table here where all their information exists only once. So you can already see the benefit of this. If the seller changes his name, you change it in the sellers table. You don't need to change it here or anywhere else. That name only exists in one place. That reduces a lot of the possibility of inconsistency and error. And it saves you disk space. That used to be really important in 1970 when hard disks were really expensive. Nowadays, it's more about the discs are cheaper, so it's more about speed. Okay, it's faster to access something if it only exists in one place, and also the flexibility, the simplicity of the database design, the limiting the possible errors that could get in. With your buyers, something similar. We had 10 bids or so, but we only have 4 buyers, so let's have their info only in one place. Now we could get even more sophisticated with this. We could say a seller and a buyer are both people, so we could just have a person table, and that is one possible. That is one way to design your database. But let's also look at this bids table. So a bid table simply has a listing ID and a buyer ID, and then the amount. So in fact, you're connecting the buyer and the listing, but you don't even need to have a listing ID in the buyer's table or a buyer's ID in a listings table. You just have this other table which associates them. So in designing your database, one of the first things to think about is what are the different tables that we need to implement and how are they going to be related together? And to do that, we have a tool called an entity relationship diagram. Now, I like to do diagrams in a program called Glyphy. It's just glyphy.com. It is free for up to 5 diagrams, I think, for students, just with an email address. And it allows you to do all kinds of different diagrams. You get your basic shapes here, your flow chart shapes. And one of the tabs here is entity relationship diagram. So this allows me to, so entity relationship diagram, let me just call this file. No, I can't give it a name. So this is my entity relationship diagram. And usually what we use is this rectangle with a, well, we can just use a rectangle like this. And in the name of it, we can put, say, seller. Okay, this is a seller who is selling a product. So let's go with, he's listing something in our auction site. And it's just a rectangle with his name. And if I want to maybe duplicate this, I think there's a button for that. I'm hitting Control and click, duplicate, just because I want another rectangle of the same size and shape. Let's say listing. So we're going to have a seller table and we're going to have a listing table. And the important question is, how are those related? Well, we're going to have in the listings table, we're going to have a seller ID. Remember, we're going to have the seller's ID number. That is going to create what we call a one-to-many relationship. And the simple symbol for that here is this line, which has what's called a crow's foot on one end and is flat on the other. So let me zoom in here. All right. So what this means is one seller for every listing, but every every listing has one seller, but every seller can have multiple listings. Okay, and sometimes we put a word on this line. Lists. Okay, the seller lists a listing. Okay, that's one way to do this. Now remember, we're also going to have buyers and we're going to have bids. So this is called a one-to-many relationship. Let me put a little label here. One-to-many, or 1:M is what that's called. And this is the most common type of relationship in a relational database. Now, our sellers, or our buyers rather, let's go ahead and put a rectangle in here for buyer. And I think my font size was, what was it, 18? It's a nice little diagramming tool. Everything works just kind of the way you would expect it to. And there's not a lot of fluff. There are tools like Microsoft Visio, which can do ER diagrams, but I find that they have a lot more busyness, a lot more stuff going on, a lot more details, whereas this is just simple shapes and lines. A listing and a buyer. If you want to think about this, we're talking about the bidding relationship. A buyer bids on listings. I'm just going to start with a simple line here. I'm going to type the word bids on. Okay, so a buyer bids on a listing. Now, A buyer can bid on multiple listings, and a listing can have bids from multiple buyers. So click the line tool here. What is the relationship type? This is called many-to-many. Okay, so these two crow's feet are a many-to-many relationship. Let's go ahead and duplicate this. Many-to-many. And we saw it in my spreadsheet, right? But in my spreadsheet, we had more than one, more than just these two tables, right? We also had a bids table. That's because in practice, you can't actually create a many-to-many relationship. What you need to do is create an intermediate table, an associative table, and you have one-to-many relationships between that table and both of the tables that it is joining together. Okay, so we're going to modify this slightly. And this is, we're going to sort of, let's do this as sort of like a gray line or something, because it, or we get colors here. Let's do it as a sort of bluish grayish line, because this is not really going to be implemented in our database. What's really going to be implemented is another table called bids, bid. Some people like to go all plural in the names of tables, and others like to go singular. So it doesn't really matter what your preference is. So between a listing and a bid is for one listing. A listing can have multiple bids on it. So that's this kind of one-to-many, where the crow's foot is on bid. Okay, so a bid is only for one listing. A listing has many bids, and we need a crow's foot that goes the other way between buyer and bid. Okay, so many-to-many, the many side is always bid. The buyer can place many bids. Each bid only has one buyer. Okay, so I'm going to delete this blue line here. That was a many-to-many relationship, but it is implemented as two one-to-many relationships. So this is that was pretty much what I modeled in the spreadsheet there. Now you can also have a one-to-one relationship. That is when one row of a certain table links to one row of another table. Now, why would you do that? Because if every row, if the row corresponds to another row, you know, why not just put them in the same table? Why not just put them in the same row of the same table? There's three main reasons I can think of. One is if the data is quite large, okay, for one of those entities. So if we think about a listing having like a photo, let's move all this down, and we'll create say a photos table. Let's say we only allow one picture in this particular auction site, and the listing has a photo. This could be a one-to-one relationship. So we'll grab a line, I'll draw a line between them, and I'll go and I'll set this tick mark here. Looks like a little cross or something on the end of the line, means one. Okay, oh, now they're all blue because I chose blue before. Let's make it a little bit thinner line. Okay, so this means one-to-one, and in fact, typically I do that on my one-to-many relationships. Is I'll put that little tick mark on the side where it's one. Okay, one-to-many. This is a one-to-one. Now you might do that because for reasons of efficiency in the database. The photo may be really big, okay, and text and numbers in a database are small. They're a few bytes, whereas a photo might be a few megabytes. And that would make the size of a row, millions of times larger on disk. And so you may want your photos table stored on a different server, or simply organized in a different way to keep that listings table working fast. This is not really a relational modeling concept. It's more like a physical sort of optimizing the database. So you might have that photo, even though there's only one photo for each listing, you don't want to put them in the same table simply because of the size difference. It could also be that the photo is optional. Okay, so one way to diagram that is we put the little 0 with the tick mark. Okay, 0, this means 0 or 1. Okay, so every photo has a listing, but listings may or may not have a photo. And so this being an optional component, we have it in its separate table so that the listing table is not full of columns that might be empty. Another possible reason is if this thing that's in this other table has different security requirements. So you might have buyer and then credit card, right? And so the buyer is related to his credit card, and it's a one-to-one relationship. But you want to give lots of people access to the buyer table. Like you have a search engine, you have commenting, you have maybe some sort of social media posting, and you don't want to give all of those programs access to the credit card. You might have the credit card in a separate table. Okay, but so the main reasons are, I think, if it's an optional thing or if it's something that you want to store separately for reasons of security or optimization. Okay, so one-to-one relationships aren't used that much. Most of your relationships will be one-to-many, or they'll be many-to-many, which, as you can see, is implemented by a couple of one-to-many relationships. Okay, so remember, these are tables. They're not rows. So when we say that seller has a one-to-many relationship with listing, what we mean is a row of the seller table can be related to many rows of the listing table. And whereas a row of the listing table is only related to one row of the seller table. Now, there is one other case for a one-to-one relationship, which has to do with concept of kind of object-oriented inheritance. So if you're a programmer, you know what that means. And if you're not, don't worry about it. But what we might say is that seller and buyer, well, they're both people, right? So we could simply have a person table, but perhaps we don't want to do that. Perhaps there is data that is specific to the seller, like reputation data or comments, or maybe he's got a paid account. And there is certain data that's related to the buyer, maybe his reputation, maybe other stuff. And so we want to keep these things in two separate tables because there's so much data in each one. We could create another table, which we'll call person. And this is the superclass. Okay, this is the generic type. And we might say that seller is a type of person, buyer is a type of person. And so you might create a one-to-one relationship between seller and person and buyer and person. Oops, I didn't want those to be optional. Actually, I do want them to be optional. I want them to be optional the other way. So a person in this case would have whatever is common to both buyers and sellers, like name, email address. They probably have a password if they're logging in, things like that. And then that person can optionally also be a buyer. Okay, there could be a row of the buyer table which is created when that person first places a bid somewhere. And a person can optionally also be a seller. So the first time he lists something, he gets a row of the seller table. But he doesn't have to be both. So this gives you a way to put that common information like username, ID, stuff like email, stuff like that in one place. You don't have that duplicated. And yet, if he's a seller and he's got a paid account, he's got a relationship and all that, you put it in the seller table and you relate them with one-to-one. So this is not exactly beginning introductory relational modeling. I don't recommend that you go ahead and do this all the time. Um, it may be overly complicated, especially if you don't have a lot of need, right? Or if your database doesn't need a lot of optimization. But I wanted to show you that one-to-one relationships, there are some reasons for them. You won't see them very often.